everyone! Today we're looking at equivalent resistance. So for this, remember, the method is going to be to identify the smallest part of a circuit as either series or parallel. In this case, this is a parallel circuit, so that's calculated by getting the equivalent resistance is the sum of 1 over R1 plus 1 over R2. Or in this case, that's 1 over R is equal to 1 over 2 plus 1 over 4. Well, using least common denominator here, that's 2 plus 1 over 4, such that 1 over R is equal to 3 over 4, so that R is equal to 4/3, or 1.33 ohms. Notice that in a parallel circuit, the equivalent resistance is less than the smallest resistor. In this case, it's easier to go through a parallel circuit than either the 2 or the 4 on its own because of the additional paths. Example 2 is in series. There's no junction surrounding these. So equivalent resistance in series is calculated by the sum R1 plus R2 plus R3, or in this case, that's 4 plus 6 plus 8, or 18 ohms. In series, the equivalent resistance is greater than the greatest. It's more difficult to go through all three of these because they represent a longer path for the electrons to go. In series, the more resistors you have, the harder it is for electrons to go. Whereas in parallel, the more resistors you have, the more paths there are, the easier it is for electrons to go. So let's speed this up. Next one, parallel. And this time it's 3 parallel. So that's 1 over R is equal to 1 over 18 plus 1 over 12 plus 1 over 36. Doing least common denominator here, that's 2 plus 3 plus 1 over 36. 1 over R is equal to 6 over 36. Therefore, R is equal to 36 over 6, such that the equivalent resistance is 6. As a double check, at the end of my circuit, since it's parallel, equivalent resistance should be less than the smallest, 6 less than 12. Now we're getting more complicated. In this case, I have 2 resistors that are acting like they're in series, 2 that are in series, and these 2 greens together, since they're in series, would represent a 12.5 and a 12.5 ohm resistor. So this green one on the top acts like a 25 ohm total. This green one on the bottom, R1 and R2 together, act like a 16.6 ohm total. Sometimes you'll see me write this in notation. So this is R3, R4 is equal to 25. R1, R2 is equal to 16.67. And doing the redraw here, this is like a 25 ohm resistor in parallel with a 16.67 ohm resistor. All in parallel with the battery. So I would take this now in parallel, so switching colors to purple. The equivalent resistance for the whole circuit then would be 1/25 plus 1 over 16.67. And in my calculator, now I probably don't want to do least common denominator in my head like I did with the previous problems. I can use instead the inverse function of my calculator. In this case, I did 1/25 plus 1/16.67. And that gives me 0.0999, etc. So 1 over R is equal to 0.099999, etc. So doing the inverse function here, R must be equal to 0.09 inverse. In my calculator, that looks something like this, giving me approximately 10 as my equivalent resistance for this whole circuit. Since this is neither in series nor parallel exclusively, I can't do this check at the end. I can't check to see is 6 smaller than 12 or is 18 greater than 8. In this case, it's somewhere in between my range of resistors because this is neither series nor parallel on its own. Okay? So, in the next section, R1 and R2 are in parallel. R3 and R4 are in parallel. Getting the equivalent resistance of each section would be 1/4 plus 1/8. I can least common denominator this. So this is 2 plus 1 over 8, or 3/8. So R34, the two resistors on the bottom, act like 8/3 ohms. R1 and R2 on the top. So I would write that as R12 is like a half plus a quarter. And that's 3/4. Taking the inverse of that, that's 4/3 ohms. Redrawing here, this is now like having two resistors in series. R12 and R34 now form a circuit that look like this, with 1.33 ohms here and 2.33 ohms here. And since these act like they're in series, the equivalent resistance of this circuit is 1.3 plus, math, 8/3 is actually 2.6, my bad. So 8/3 is 2.6. And that means my equivalent resistance is approximately, 4 ohms. Okay? So we're going to repeat this, and now that the problems are more complicated, I give you more space. I've also asked you to use this 1, 2, 3 format. What I mean by that is, let's say I needed to figure out R1 and R2 first. I would show that I'm getting the equivalent resistance of this section by showing R12, so that's both resistors put together, so that's not 12, it's 1 and 2, is equal to 1/2 plus 1/3. Ooh, math in my head here. That is 3/6 plus 2/6, or 5/6. R12 is equal to 6/5, or 1.2 ohms. R4 and R5. I'm going to use that subscript format. That's 1/R45 is equal to 1/R4 plus 1/R5, or in this case, that's 1/8 plus 1/2. Least common denominator here is 8, so that's 4/5 is equal to 1/8 plus 4/8, or 5/8. Taking an inverse here then, R45 is equal to 8/5 is equal to 1.6 ohms. Redrawing. I finally can get the equivalent resistance of this whole circuit because it's all in series. I have R12, R3, R45, both of those together, and R6. Since they are all in series, there's no junctions left. I'm just going to add them up. This gets me an equivalent resistance of the entire circuit is 1.2 plus 3 plus 1.6 plus 0.2. And that gets me an equivalent resistance of 6 ohms. I'm showing all my work in steps. I'm using the R123 format so that each small segment of my circuit can be substituted. In this case, R12 and R45 were treated separately in these 2 steps. And the third step is this one at the end. If you're a step-by-step person, then here's what my steps would be written out as. I would break down my circuit into the smallest possible segments that are either all in series or all in parallel. R1, 2, 3, those two put together are all in parallel, so then I would apply the parallel equation to that segment. I could probably least common denominator this, but honestly, I'm not going to be able to do that live in my head easily. So what I'm going to do instead is I'm going to do 6 inverse plus 4.5 inverse plus 6 inverse. I know 1 over R is equal to that 0.55 number. So 1 over R123 equals 0.5 repeating. That means using the inverse function, that section of the circuit is equal to 0.55 inverse, or about 1.8 ohms. And I just need to repeat this step. So my step would be find the segment of the circuit that's all series or all parallel. Apply the subsequent equation that goes with it. Solve for that segment's equivalent resistance. So in this case, I'm totally going to calculator this. You knew I would do that. All right, I don't want to do this in my head. 9.33 inverse plus 4 inverse. That's equal to 1 over R is equal to 0.35, 0.36. Inverse of that gives me the 2.8. And I'm going to repeat this until I've simplified the circuit. In doing this, I now have a circuit that has the battery. Battery stays in the same place. I'm going to replace this purple segment with R1, 2, and 3, which was the 1.8 ohms. R4, R5 got replaced by 2.8 ohms. Now this is all in series, and my last step would be to add it up. 1.8 plus 2.8 is equal to, I don't know, 4.6 ohms. Ta-da! All right, good luck, guys.